Okay, Assalamualaikum and good evening, everyone. Welcome back to the lecture of Research and Empirical Methods in Computer Science, CCF 591. Right? Today is 1st January 2021. Happy New Year, everyone. So let's continue with our fourth lecture. Yeah. Okay. So for today, we're going to discuss on the statistical hypothesis testing. We're going to develop the hypothesis testing. What are terms that is related to the hypothesis testing? Okay, I'm going to introduce you to all in this fourth lecture. Right. So before that, let's recap back what we have go through on last week class. Okay, we already discussed on EDA and specifically on sampling and also how you're going to display and summarizing your data. Right. So do remember there are 4 steps. Yeah, generic steps. 4 generic steps in EDA. What is the first one? The first one, when you get your data first, you need to understand your data. Okay, you need to check how you're going to understand your data. You need to check the first 5 row data. You need to check the last 5 rows of your data and also check what is the total number of rows and columns of your data that you have, and also summarize the data into a descriptive statistic, which includes mean value, standard deviation value, minimum and maximum values, and also the Q1, Q2, and Q3 values. Also, it also helps you to understand more of your data if you know what are those the column name that you have, right? So that is all the things that you need to do in step 1, right? So what you need, then we go to the step 2, which is we going to clean up the data from any noise, or any bias or any outliers. Also, in this step, it is advisable for you to drop any unnecessary column data that is not related to your research experiment, right? So your data will be clean, okay, from unnecessary data, right? So for the third step, you need to do some relationship analysis, right? Any correlation, to see any correlation among the selected variable, and to see how the dependent variable depends on the independent variable. Okay, the last step in the EDA, you need to plot the analysis data in the graph, either in scatter plot, box plot, line plot, or any other graph that is suitable to your analysis result, right? Yeah, and also do remember, what is the differences between the analysis techniques, which is univariate, bivariate, and also multivariate analysis. Okay, do remember, the selection of the data analysis technique, either it's univariate or bivariate or multivariate analysis, will be depends on the number of the variable that you have, or the type of data, and the focus of the statistical inquiry. Okay. And also for the sampling method, do remember why we only focus on the random sampling, and what are those random sampling? The first one is the simple random sampling. The second one is stratified random sampling. The third one is systematic sampling. The fourth one is the cluster random sampling. Okay, and the fifth one is the convenience random sampling. Okay, so do remember when we're going to use this one, what is the differences between all of these sampling? Yeah, and then for the last topic is on this displaying and summarizing your data. Okay, so do know how you're going to represent your data in the dot plot or in the box plot or even in the histogram. Okay, there is more charts, but we only cover these 3 charts, right? Now, for today, uh, lecture, I'm going to discuss about the statistical hypothesis, on its procedure, on the statistical test, what are the exact tests, and also what is the mean of the p-value, one tail and two tail. Okay, so this is for today. So the reference from the main reference, chapter number 9. Okay, so what is, we begin, yeah, with a question, what is a hypothesis? Okay, so in a simple term, hypothesis is referred to one hunch or an assumption that we want to prove or disprove. Hypothesis is the essential tool for research. It's a fundamental tool for research in any kind of your research investigation. Okay, in fact, yeah, it is the second step for us to follow in any kind of research process. This is the second step. What are the first step? What are the first step? First step is you need to formulate your research problem. Then we're going to continue with developing your hypothesis, right? So this hypothesis here is a tentative solution of a problem. The research activities are planned to verify the hypothesis. So all of the researcher always plan or formulate, yeah, a hypothesis in the beginning of the research activity, right? So what are the main role of hypothesis in the scientific research that we do, right? So the hypothesis is an important instrument in scientific research. In fact, many experiments are designed specifically to test one or more hypotheses. In many domains, true population parameters for the data is unavailable. Yeah, normally it's not available. It's too big, the real population. So we're going to take only a sample size. Okay. So the sample statistics are used instead. So here, yeah, the hypothesis testing is used to validate if the sample data that we took offers support for a hypothesis that generalization can be made to the real population. Okay. So for a researcher, yeah, the hypothesis is like a formal question that he or she intends to resolve, right? So for example, yeah, question like whether algorithm A will produce better result than algorithm B, right? So is there any significant differences between a new drugs and one in a treating cancer? Right? So this is where we need to use the hypothesis. Okay. So this hypothesis can be objectively verified and tested. So the following are the main function hypotheses in the research suggested by McAshen 1979. Right? First is a temporary solution of a problem concerning with some tools. Right? The second one, it will offer you a basics, yeah, in establishing the specificity what you want to study. Right? So the third function is each hypothesis may lead to formulate another hypothesis. Right? So the last one, each hypothesis will provide the investigator with definite statement. Right? Okay. So what is the importance of the hypothesis? Okay, the first one, it acts as the investigator eyes. Okay, it thinks that by guiding the investigator in further investigations, it will serve as the investigator eyes in seeking answers to tentatively adopted generalization. Right? So the second one is it will focus your research. Okay, without the hypothesis, yeah, the research is unfocused and remains like a random empirical wandering, right, in the open space, right. So it will serve you. So the hypothesis will serve as necessary linkage between theory and the investigation, right. So the third one is it places the hypothesis will place a clear and specific goal for your research. Right? So a well thought out hypothesis is that which places clear and specific goals before the researchers and provide him or her with a basis for selecting sample and research procedure to meet this goal. Right? So the fourth important about hypothesis is it links things together. It links things all together. Okay? So it serves the important function of linking together the related facts and information and organizing them into a whole. Right? The last one is it prevents you from blinding the research. Okay, so it prevents blind research. The use of hypothesis is it prevents a blind search and save the researcher from gathering of masses of data which may later prove irrelevant to the study. Right? So here is a diagram, yeah, a flow if we want to develop a hypothesis. Okay, the first step is you need to state, yeah, the hypothesis, the null hypothesis. Alright? Okay, you need to state the null hypothesis. Okay, and then also the alternative hypothesis. Right? This is after you take you you take a sample from a population. Right? So for the step 2, you need to set the criteria for a decision. Right? Whether you want to reject it or not. In this case, we use level of significance. The criteria is the level we set the value for a level of significance. Right? Also, in this case, we're going to select a sample, yeah, from the population. Okay, and then we're going to measure the sample mean of the sample. Right? So in the step 3, we're going to compute, yeah, the test statistics. Okay, so it will produce the value. Then we can compare, yeah, the criteria that we set. Right? Okay, in the step 4, we're going to make a decision. Right? Based on the level of significance that we have, whether the p-value that we have. Okay, so if we set the level of significance to 5%, okay, and if the null, so we set the level of significance to 5%, yeah, okay, which is we are 95% confident with our result, right? So when the null is true, then we reject the null hypothesis, yeah. So if the probability of obtaining a sample mean is more than 5% that we already said at the beginning, then the null is true. Then we need to retain the null hypothesis, right? So what is the null and alternative hypothesis, yeah? As we said in the step 1 here. So, okay, the null hypothesis states there is no relationship between the measured phenomenon, which is the dependent variable, yeah, and the independent variable, right? So you do not need to believe the null hypothesis is true, right? So on the contrary, often you suspect there is a relationship between a set of variables, right? So the null hypothesis is used as the basis of an argument because it's possible to test it, right? So rejecting a hypothesis does not mean an experiment was bad or that it didn't produce any result. It's to distinguish it from other form of hypothesis, right? So the null hypothesis is written as H naught, okay, H naught or H null or H zero, right? So a significant test is used here to determine the likelihood the results supporting the null hypothesis are not due to chances, right? So a confidence level of 95% that we set or 99% is common, yeah? So we normally set 95, or if you're confident enough, we're going to set it to 99%. Okay? So keep in mind, yeah, even if the confidence level is high, there's a chance the null hypothesis is not true. Is not true. Right? Perhaps because the experimenter did not account for a critical factor or due to the chance. So this is one reason for important, yeah, for us to repeat again the experiment. Okay? I remember last time I did my experiment, I ran it like 10 times for every simulation just to get a very confidence value, right? So what is the alternative hypothesis? Okay, so the alternative hypothesis here reflects that there will be an observed effect for our experiment. Okay, in a mathematical formulation, of the alternative hypothesis, there will typically be an inequality or not equal to symbol, right? So this hypothesis is denoted by either HA or by H1. Okay, so the alternative hypothesis is what we are attempting to demonstrate in an indirect way by the use of our hypothesis test. If the null hypothesis is rejected, then we accept the alternative hypothesis. If the null hypothesis is not rejected, then we do not accept the alternative hypothesis. So if we are studying a new treatment, then an alternative hypothesis is that our treatment does, in fact, change our subject in a meaningful and measurable way, right? So here is an example, for alternative hypothesis and also null hypothesis. Okay, so example, if we are interested in deciding whether the mean writing speed of hard disk drive is 50 milliseconds, so we can express this formally in two hypotheses, which is null hypothesis and also alternative hypothesis. So for the null hypothesis, average speed of sample is equal to 50 milliseconds, while alternative hypothesis is that the average mean is not equal to 50 milliseconds. So do remember, when we develop the null hypothesis, we only use the equal symbol for the null hypothesis. Okay. Okay. Now, so here are some examples, for the null hypothesis. Let's say the research question is, are teens better at maths than adults? Right? So the null hypothesis would be age has no effect on mathematical ability. What is the possible alternative hypothesis would be? What be the possible alternative hypothesis? Maybe you could say for the alternative hypothesis is age has an effect on mathematical ability. Okay, so that will be some example of alternative hypothesis. Right? So for the second research question is, does taking aspirin reduce your chance of having a heart attack? Okay, so the null hypothesis will state taking low dose aspirin daily does not affect heart attack risk. So what now, in this case, what would now be the alternative hypothesis? So the alternative hypothesis in this case would be taking low dose aspirin daily will affect heart attack risk. Okay, so the second research question would be, do teens use a cell phone to access the internet more than adults? Then the null hypothesis would be, age has no effect on when a cell phone is used for internet access. Okay, so the alternative hypothesis for this case would be, age has an effect on when a cell phone is used for internet access. Okay, so the fourth research question would be, do cats care about the color of the coat of the food? Okay, the null hypothesis is cats express no food preferences based on color. So the alternative hypothesis would be, cat express food preferences based on color. Right? The last research question would be, does chewing willow bark relieve pain? So the null hypothesis would be, there is no differences in pain relief after chewing willow bark versus taking a placebo. Alright, so the alternative hypothesis for this case is, there is differences in pain relief after chewing willow bark versus taking a placebo. Right? So you can see now here the difference between the null and alternative hypothesis. Anything that null hypothesis say positive, the alternative hypothesis will say it in the negative side. So it negate statement of null hypothesis. hypothesis. Yeah. Okay. So this is the following set of negation may help when you are forming your null and hypothesis alternative hypothesis. So when you say the null hypothesis x is equal to y, so the alternative hypothesis is x is not equal to y. So when you state your null hypothesis is x is at least y, so alternative hypothesis will say x is less than y. Okay, so last one, last null hypothesis. When you state your null hypothesis is x is at most y, so your alternative hypothesis will be x is greater than 1. Okay? Okay? So here an example of alternate hypothesis. Okay, so the alternative hypothesis state that children watch less than 3 hours of TV per week, or children watch more than 3 hours of TV per week. So the alternative hypothesis, if we combine, it will state that children do not watch 3 hours of TV per week. So here in this case, what is the null hypothesis? What is the null hypothesis? The null hypothesis is children watch TV equal to 3 hours per week. Okay? So we want, when we get the result here, how we're going to conclude the test hypothesis. Okay? So if we reject the null hypothesis, it means that we conclude that there is enough evidence to infer that alternative is true, right? So if p-value is equal to less than level of significance, then we're going to reject the null hypothesis. So what it means here if we fail to reject the null hypothesis? So in this case, we conclude that there is not enough evidence to infer that the alternative hypothesis is true, right? But however, it doesn't mean that the null hypothesis is true also. Okay, so we need to develop another hypothesis, another alternative hypothesis. Okay, so here is a general step in developing the null and alternative hypothesis. Okay, the first step is the first step of procedure is to state the hypothesis null and alternative form. Okay, convert your research question to the null and alternative hypothesis. Okay, so the null hypothesis use H dot, okay, is a statement of no difference in the population, while the alternative hypothesis claims that null hypothesis is false, right? So we need to collect and seek evidence against the null hypothesis as a way of supporting the alternative hypothesis. Okay, so I'm going to give you another example of null and alternative hypothesis. How we're going to develop the null and alternative hypothesis. So here is the problem. In the late 1970s, 20 to 29-year-old men in the United States had a mean body weight of 170 pounds. The standard deviation sigma was 40 pounds. So we want to test whether mean body weight in the population now differ. Okay, so the null hypothesis would be mean is equal to 170 pounds. 70 pounds. Okay. So under the null hypothesis, there is no differences here in the mean body weight between then and now. So in which case mu would be still equal to 170. So that is the null hypothesis. Okay. So for the alternative hypothesis, okay, the mean weight has increased. Therefore, alternative hypothesis is mean could be greater than 170 pounds, for one-sided test, or we can state also mu is not equal to 170 pounds. So it can be two-sided test. Okay? Yeah. There is another way to state the alternative hypothesis. We could state it in a two-sided manner, looking for values that are either higher or lower than expected. Alright? So for the current example, the two-sided alternative is the average value is not equal to 170 pounds. Okay? So this is the level of significance that we need to set, yeah, to test the hypothesis. Okay? So level of significance is an important choice in hypothesis testing, right? It refers to the risk the experimenter or researcher is willing to take of rejecting the null hypothesis when it is true, right? So for example, if the level of significance is 0.05 or 5%, then it implies that the null hypothesis will be rejected when the sampling result has less than 0.05 probability of occurring if null hypothesis is true. Okay, so the significant level is the maximum value or of rejecting the null hypothesis when it is true and is usually determined before testing the hypothesis. Right? So there are many values that we can set, yeah, for the level of significance, either it's 0.1, 0.05, or 0.01. Right? So it's relatively little justification, okay, why a significant level of 0.05 is used rather than 0.01 or 0.1. Okay, but it is widely used in academic research. Yeah, we'll normally set at 0.05. But however, yeah, if you want to be particularly confident in your result, you can set a more stringent level to 0.01. It means that 1% chance or less, right, that the null hypothesis is true. Alright. So typically, yeah, we don't use many value. We didn't set multiple significant value, multiple level of significance. We just choose only one. If we choose 0.1, then we stick from the beginning until the end the 0.1 value, right? So traditionally, experimenters have used 0.05 level, yeah, it's called conservative value. Okay. So here is the critical values and regions. Okay, so you can see here, the critical region is a region the critical region is a region that is outside the acceptance region. Okay, so what is the critical region actually? So it's a set of all value of the test statistic that would cause a rejection of the null hypothesis. Okay, so what do you mean by critical value? So value or values that separate, yeah, the critical region from the value of the test statistic that do not lead to a rejection of the null hypothesis. Okay, so this critical value, yeah, is the value that separate the critical region from the acceptance region. So I'll give you some example. Yeah, consider a hard disk writing speed problem. We wish to test the null hypothesis that is the speed is equal, the average speed is equal to 50 milliseconds, and the alternative hypothesis is that the average speed is not equal to 50 milliseconds. Okay, suppose that, yeah, the sample we took is 10. Okay, so 10 sample is tested and the sample mean is observed. Yeah? So if the value of the sample mean is close to the hypothesis value of mu equal to 50 millisecond, okay, so there is no conflict with the null hypothesis, meaning that if the value is between 48.5 to 51.5, then it's accepted region lah. It's still in the accepted region, right? But on the other hand, if the sample mean is significantly different, yeah, from 50 millisecond, then we need to reject lah the null hypothesis. It will not support the alternative. Okay. Now here's a value, critical value at a given level of significance. Okay. So if you set your significant level to 0.05, if your test is 1 tail, so the value would be the level of significance. The 1 tail value would be plus 1.645 to minus 1.645. Okay, so it just extra knowledge, right? Okay, so there are two types of popular test statistics that we're going to test for our statistical hypothesis. One is z-test and another is p-value method. Okay, so the test statistic is a mathematical formula that allows researcher to determine the likelihood of obtaining sample outcomes if the null hypothesis were true. So the value of the test statistic is used to make a decision regarding the null hypothesis. Okay, there are two popular ways to conduct statistical hypothesis testing. Okay, the first one is z-test, when the mean and standard deviation of a single population is known. Okay, and the second one is p-value method, is the probability of obtaining a sample outcome given that the value stated in the null hypothesis is true. Okay, so in hypothesis testing, yeah, z-test for hypothesis testing is computed and compared against the critical value in a standard normal table. Okay, so the statistic is the Z statistic is an inferential statistic used to determine the number of standard deviation in a standard normal distribution. That a sample mean deviate from the population mean stated in the null hypothesis. We want to see how the standard deviation deviate, yeah, from the sample mean, right? So if Z statistic fall within the critical region, then we reject the null hypothesis. Otherwise, do not reject the null hypothesis. So here is the p-value test. It's actually the probability of obtaining a test statistic more extreme. Okay, so it equal, less than, or greater or less than actual sample value given by null hypothesis is true. Right? So this is also called observed level of significance. Okay, so the smallest number of null hypotheses that can be rejected. Let's say if p-value is greater or equal than significant value, we do not reject the null hypothesis. If p-value is less than or equal to significant value, then we need to reject the null hypothesis. Here is the summary steps for hypothesis testing. First, you need to formulate your null and alternative hypothesis. Then you need to select the appropriate test, and then you choose your level of significance, whether it's 0.05 or 0.1 or even 0.01. Then you're going to calculate the test statistics, right? And then you need to do some significant level, comparing the significant level, whether you want to reject or accept the null hypothesis, and then you draw your own conclusion. Okay, so here is the conclusion for today's lecture, right? So the hypothesis testing provides you a means to make important decisions about your empirical experimental result. Okay, so the hypothesis testing is by itself is not a decision-making process, but it's just a tool to aid the process in making decision. So therefore, a proper interpretation of the result of hypothesis testing are crucial. Okay, so it should be noted that all hypothesis tests are bound by probabilities, and error can be made. They are type 1 and type 2 errors. Right? So a good judgment combined with knowledge of subject matter is the key, yeah, and also the aid of the result from the hypothesis testing. So it can make our experiment result more valid with the help of the hypothesis testing. Alright? Alright. Thank you and see you in the next lecture.